So if you notice up top on your notes here, first thing I did is I went through those vocabulary words again. You need to know these vocabulary words. Domain and range. Domain is your x values. Range is your y values. Positive and negative. You have to keep in mind if you're on your graph, your positive is above your x-axis. So this is positive. Those ones are negative because it's where your range values are positive and negative. That's how we determine that. And then we're going to be talking about also today a maximum and a minimum. Maximum is your highest point. Minimum would be your lowest point. If you are struggling with your vocabulary, go to Quizlet. I have all the vocab words in there so you can study. You can do little flashcards. There's other little games that they put together for you so you can practice your vocab words. You need to be doing that. A lot of times what I find happens is when you're reading through the problem, you get stuck because you don't know what the vocab word is. So you got to practice the vocab words so you know what they are as you're going through these. All right, so first thing we're talking about is how to identify a linear function versus a nonlinear function. It's a pretty easy concept. Linear functions form straight lines. So like this horizontal line or diagonal line here, those points still make a linear function. It still creates a straight line. We got our horizontal line there. There's only one kind of line that's not a linear function. Does anybody think they know? Josh? What is that called? Vertical. Non-vertical lines. It can't be a vertical line because remember, a vertical line is not a function. It fails your vertical line test. So keep in mind, if I were to have a vertical line like here, try to do my vertical line test, I draw a vertical line on it and it hits it at every single point. So it would fail a vertical line test. It's not even a function. So our nonlinear functions is a function whose graph is not a line or part of a line. So like for example, this one here, clearly it's nonlinear, does not make a straight line. It's got a little curve. This one also has a little curve to it. And then this graph we did last class. What do we call that graph? We did an entire day. Absolute value. That's our absolute value graph. It makes the V shape. So these three graphs down here, they want us to decide if it's a linear function or a nonlinear function, and we have to explain how we know. So A, is that linear or nonlinear? Nonlinear. This is a nonlinear function. How do we know? Because it has a curve. So let's see if you can figure out B and C on your own. Put an explanation, and then we'll see how you did in a second. So graph B, what kind of function is it? Linear. How do we know it's linear? Because it's a straight, non-vertical line. That's the key thing. It's not a vertical line. All right, how about C? Non-linear. Why? Because it's curved. Non-linear. Because it's curved. So the majority of our functions that we're going to be doing are actually nonlinear functions. So we're going to get used to those curves. Since they're nonlinear, we don't use rulers when we draw pictures of them. So what we're going to do is we're going to go through all the different kinds of functions that we need to know this year in Algebra 1. And then we're going to go through and practice our increasing, decreasing, and behaviors. We're going to be practicing all those skills again today. So this first function, f of x equals x squared, this is called a quadratic function. So with our quadratic functions, when you go to graph it, you need to get a table of values so you can have your points to graph. so let's go to our calculator. All right, so in our calculator, we're going to go to the y equals because we're graphing it. I need to clear the stuff out that I had in there. If you have this in your calculator over here, this little arrow guy, because you're borrowing one of my classroom calculators, just go over so that your little blinky guy's on it, and then you hit enter until you get a straight line again. There we go. So then again, we're trying to graph x squared. So we're going to type in x using our little xt theta n button. And then you're going to push the x squared button. That gives us our exponent of 2. So we got our function x squared in there. So we'll take a look at our graph. And this forms a U-shaped curve, as we call it. So what happens is these values right in here are going to repeat themselves. Our y values are going to be the same. Because whether I'm here or here, they both have a y value of 1. Here and here both has a y value of 2. Same thing with your 3. So we want to look at our table, and we need to find a pattern. So I need to arrow down. And here's the pattern I'm talking about. In your y column, your top and your bottom number are the same. Then those next two are the same. Then those next two are the same, and then you've got one in the middle. That's your pattern for your quadratic. So once you have that, go ahead and copy it down into your table. And then you can go ahead and plot your points. Again, remembering to extend your curve all the way up to it goes off the graph. Want to put arrows on it and label with the equation f of x equals x squared. So a couple of little things about this graph before we actually get into figuring out this stuff. The shape of the graph, it's a U shape. We refer to that as a parabola. So that may go back and forth. You may hear them call it a quadratic function, or they may talk about the parabola shape. That's the same thing. Okay. So let's practice these. Increasing and decreasing. I drew my little line here because I'm going to write my increasing interval here, my decreasing interval over there. So if I start on the leftmost point of my graph and I start following it, am I increasing or decreasing right now? When do I stop decreasing? When x is 0. So if I look at my x values when my graph was decreasing, I have -1, -2, -3, -4. Those values are what than 0? Less than. So I am decreasing when x is less than 0. So after 0, my graph changes and it starts increasing now. So for what x values is it increasing? The ones that are greater than 0. Our end behaviors, these are the easier ones. Which way is my left side of my graph going, up or down? Up. Left side's up. Right side is also up. Does my graph here have a maximum or a minimum point? Minimum. It's got this point right here, which is the lowest point on the graph. Nothing will be lower than that. So my graph has a minimum at the point 0, 0. So again, I'm going to draw my little line down for domain and range. I'm going to write my domain underneath the word domain, my range underneath the word range. So domain first, we have arrows on the end. Could it possibly be every single x value available? Yes. Because of the arrows, it's going to keep going. So x is an element of the reals. Looking at our range, though, can it be every single y value? No, it's never going to be these negative numbers down here. The graph's never going to turn and go back down. So our range would be y is greater than or equal to 0. And then positive, negative. Remember again, positive is above your x-axis. Negative is below the x-axis. Is our graph ever negative? No. So negative is a little line. It's never negative. Now here's the one thing I didn't get into just yet with positive. The whole thing is positive except for right here, because 0 is what? 0 is neutral. 0 is neither positive or negative. It's just 0. So for positive, we have two ways that we can write it, and you can really choose either of the two ways. We can say x is an element of the reals, comma, x cannot equal 0. So that means it would be positive for every single number except for when x is 0. Or the other way you could write it is x is less than 0 and x is greater than 0. So you're saying it's positive when x is less than 0 and when it's greater than 0. So either of those two ways doesn't matter. What was that, Tanner? X cannot be equal to 0 because then it's not positive. So, can't equal 0. All right, number 2. This is our next kind of function. Does anybody know what kind of function this is? What's this symbol called here? Square root. So this is a square root function. So let's go ahead and put this into our calculator. So again, we're going to go back to our y equals, clear out what we had in there, which was our x squared. To get your square root, you have to push the second and then the x squared button. And then you type in your x. So second, x squared, and then you type in your x. So if you look at your graph, you should have a graph that looks like that. It has a slight curve to it. Yep. If we look at our table, we have a few in here that are errors. Do you know why our negatives would be errors? You can't take the square root of a negative number. So that's why it says error in your table. You want starting with 0. Well, bless you. -1 was another error, so we'll put error in our table there. 0, 0, 1, 1. You can skip around to all of the whole numbers, which is what I did in my table.
2.
So I skipped to 4, which is 2, and then 9, which is 3. You don't have to graph the decimals. It makes your life easier not to graphing the decimals. So I'll go over here 0, 0, 1, 1, 4, 2, 9, 3. We will have an arrow on the right side of the graph only. Because of the errors, it does not continue past the 0, which is why there's no arrow on our arrow on our left side. And then we label g of x equals the square root of x. Now this graph doesn't have a special name to it. It's just a square root function. So let's practice again our increasing, decreasing, and all that good stuff. So if I start on the leftmost part of my graph, what is my graph doing? increasing. Is our graph ever going to be decreasing? No. So I'm going to put a little line under my decreasing. For what x values is it increasing? Joe? Perfect. When x is greater than 0, it's increasing when x is 1, 2, 3, 4, not any of the negatives. End behaviors for this graph, there is no left side end behavior because there's no arrow. It terminates. So you would just do right side. It's going up because the right side is increasing slowly, but it is increasing. So that's why its right side is up. Do we have a maximum or minimum? We have a minimum. Where is our minimum? 0, 0, right here. It's our lowest point. Nothing will ever be lower than that. All right. Domain and range. What x values are we using? Caitlin, you think you got it? Well, we got the arrow, so it's going to keep going that way.
Yes,
it's not going to be XER. We don't have arrows on both sides. Josh? X is greater than or equal to 0. Because our x values start at 0, and then it's going to be everything higher than 0. This is the only function where your x is not an element of the reals. Our range would be what? Y is greater than or equal to 0. Because again, our lowest y value is at 0. It's going to be everything higher than it. It's going to take a while to get up there, but it can be everything higher than that. Then positive, negative, is our graph ever negative? No. I'm going to put a little line underneath my negative. It's never negative. When is our graph positive?
When it's above 0.
When it's above 0. So when x is greater than 0, our function is positive. Seems like we're starting to get a little bit better with these. That's good. All right. Let's try our next one. Now, if you look at the equation, this one looks very similar to our last one. But this one is slightly different. Does anybody know what this one would be called? It's got this little 3 here. Ah, so close. Cube root. This is a cube root function. So let's go to our calculator. Go back to our y equals. Clear it out. So to get the cube root, you're going to go to math, and then choice 4 right there is your cube root. So we pick the cube root and we type in an x. And then you arrow over once to the right to get out of your cube root. So your graph should look like that. You would go math, and then choice 4 is your cube root. So let's take a look at our table. So again, our table for our cube root has a lot of decimals. So you want to move around your table to get the whole numbers because that's going to make your life a lot easier for graphing. Now on our graph here, our lowest value is negative 10. So in my table, I look to where negative 10 is. That gives me a decimal, so I'm not going to use that one. My first point I'm going to use is negative 8, negative 2. And then I already filled in for you what negative 1 was, so let's go find 0 and 1. Yeah, 0, 0, 1, 1. So once you got your table filled in, go ahead and plot your points. Yep, this one has 2 arrows. It does continue on past your negative 8. We just didn't write it in our table because it was a decimal. So we get h of x equals the cube root of x. Make sure you label your graph. Yeah, this one was h. Is this graph increasing, decreasing, or both? It's not both. Remember, if we start on the left and I follow my line, it's increasing the whole time. Parts of it are increasing very slowly, but they're still increasing. So this graph is never decreasing. So what are those three letters we write when it's increasing the whole time? X is an element of the reals. Our graph is always increasing. End behaviors. We can do end behaviors for both sides this time, left and right. Again, it's very slow, but the left side is going down. Yep, and then the right side is very slowly going up. Do we have a max or min? No, because we got arrows on both ends. This thing's going to keep going. No max or min here. Okay, domain and range. What would be our domain? Joe's got this. X is an element of the reals. Our domain could be everything. That graph is going to keep going to use all of our x values. The only thing with range, though, is we got to put y. Y is an element of the reals. It will keep going up and down, and it'll take a very, very long time, but it will eventually use every single y value that is available to us. All right, positive and negative. We have a part that's positive, and we have a part that's negative for this graph. It changes from positive to negative right there when x is 0. So when x is less than 0, so these values over here, are we positive or negative? Negative. So when x is less than 0, our graph is negative. So therefore, when's it positive? When x is greater than 0. All right, here's our last one in our notes today. We have j of x equals 2 to the x power. This is called an exponential function. It's called an exponential function because your variable, your x, is in the exponent spot. That's how it's different than our quadratic where it was x squared. You had a number in your exponent. When the variable is in your exponent, it becomes an exponential function. So we'll go to our calculator, go back to your y equals, clear it out. To get our exponential, we're going to type in our 2. And then this little caret button right here underneath the clear gives you an exponent. And then you put your x in there. And then you make sure you arrow over once to get out of the exponent. So then if you look at your graph, you get a little curve like that. That's our exponential curve. Yep, so when you graph your exponentials, you want to have a couple of decimals in your table, and then the rest of them should be whole numbers. So our negative 2 would be 0.25. Our 1 is what? 3 is 8. So I always graph my whole numbers first. So I start with 0, 1, 1, 2, 2, 4, 3, 8, 4, 16. And then I do my decimals, like negative 1.5 means I'm going to go up half of a box. And then 0.25, less than half of a box. You're just kind of estimating with your decimals. So and again, you want to connect your points, make your curve. Yep. So j of x equals 2 to the x, we label it. We're going to do a whole unit about exponential functions later on in the year. Yep, these little curvy lines. Okay. So let's figure this out. Is this graph increasing, decreasing, or both? Increasing. It's never decreasing. So again, if you start on the left, you follow your curve, it's going to be increasing the whole entire time. So when it's increasing the whole time, its x is an element of the reals. End behaviors, left side is down, right side is up. Do we have a max or min? No. None. What would our domain be? Got arrows, so it's going to keep going. Will it eventually use every x value?
Yes.
Yes. So x is an element of the reals. Now for our range, and we're going to talk about this more when we get into our exponential functions unit. Your exponential function has this little line right here. We draw it as a dotted line because it's an imaginary line. We don't actually write it in there. It's called an asymptote. Asymptote. So what an asymptote is it means the graph approaches it and it gets closer and closer and closer, but will never actually touch or cross that line. So when we write our range, since this asymptote is at 0, that means our range is entirely that y is greater than 0. It will never equal 0 and it will never be less than 0. Even though it looks like it will, it never actually will. So then for our positive, negative, will this graph ever be negative? No, this graph will never be negative because it's never going to go underneath 0 because that's our asymptote. So then that means the whole thing is positive. So how do I write that? X is an element of the reals. So between this, your linear functions, and your absolute values we did the other day, these are the functions that we need to know this year. So you need to know them by the kind of equation they are. So you have to be able to recognize the hints. You have to be able to recognize them by the graph. So you need to know that this little curved line like this means it's an exponential function.